right, so we're going to take a look at solving a system of equations, in three variables. So you have three variables, three equations. Remember in class I showed you that typically I like to number my equations so I can let myself know what I'm actually going to be adding together with the addition method. And it also, helps you to keep yourself organized when somebody's talking about them or you are talking about them, if you know which one's which. So what I would suggest anytime you're dealing with three variables, yes, the substitution method will work when some of them are really nicely set up for substitution. I'm not saying you can't use it, but I would suggest kind of sticking with the addition method, because if you look at equation 1 and equation 2, these z's are going to cancel immediately. So we can take equation number 1 and we can take equation number 2 and we can add those two equations together, because we don't even have to multiply these because they are already opposites. So what we're looking for when we are dealing with a system of three variables is we are looking to try to get rid of one of the variables. So we cancel out the z here in this one. X and 2x is 3x. 3y and 1y is 4y. And then negative 11 and 1 is negative 10. Now, what we have here is we have an equation that only has x and y. We need another equation with x and y only, and we can find the solutions for x and y. So what I showed you in class is that if you come back up here to these three original equations, and you find two equations that are not equation 1 and 2 together, we could say 2 and 3, or we could say 1 and 3, and we cancel out the z's again. It has to be the z values again. So my suggestion on this one is to take equation number 1 and multiply it by 3. Because if you multiply this equation right here by 3, you are going to get a negative 3z, which will cancel out with the positive 3z in equation number 3. So what I do is I take equation number 1 and multiply by 3. 3 times x is 3x. 3 times 3y is 9y. 3 times negative z is negative 3z. And then 3 times negative 11 is negative 33. And that's just multiplying all of those by 3. You take equation number 3 and you write it right underneath equation number 1, and then you add those together. The z's cancel again. If the z's don't cancel again, you are doing this wrong. If you are trying to cancel out z's over here in the first one, you should also cancel out z's over here in the second one. Because what it gives me is 3x and 5x is 8x, 9y and negative 2y is 7y, and then negative 33 and 21 is negative 12. Now I have two equations that only have x and y. And so what I can do essentially at this point is I can ignore all those equations up here that had z in them, and I can just focus in on these two equations and solve it like we have been for the entire first part of this chapter with two variables, two equations. So I use the addition method again. What it would end up doing on this particular problem is I would multiply this equation by 8. The reason I would multiply it by 8 is because 8 times 3x is 24x, 8 times 4y is 32y, 8 times negative 10 is negative 80. Yeah, those numbers are a little bigger, but now I can multiply this equation by negative 3. So I multiply this equation right here by 8. I multiply this one by negative 3, because what it does is it gives me negative 24x, and there's opposites again. Negative 3 times 7 is negative 21y, and negative 3 times negative 12 is positive 36. So now I do not have to go through and worry about the x's anymore because they will cancel out. That's the addition method with two variables, just like we did the addition method with three variables. You're canceling out one of the variables. The good thing about with two variables is once you cancel it out, you get 32y, and negative 21, that's 11y. Negative 80 and 36 is negative 44. What you have now is this little equation. Wow, sorry about that. You have this little equation here. You can just divide by 11, and y is equal to negative 4. And so you've got your answer for y already. You use this to plug in and find x. My suggestion would be to plug it in over here into this one. So you get 3x plus 4 times negative 4 equals negative 10. That gives you negative 16. When you add 16 to both sides, you get 3x is equal to 6. Divide by 3, you get x is equal to 2. So you have your x value and you have your y value. Now all you need is to get your z value. But notice that solving this is exactly like what we did with just two variables earlier in the chapter. So the tricky part on the three variables is this first step right here, getting the z's to cancel and getting the z's to cancel again. Don't choose a different variable. If you cancel out the z's in this first step right here, you cancel out the z's in this second step right here. You have to. So final step on this one is to take 2 and negative 4, plug it into one of these up here and find z. My suggestion would be to plug it into the second one right here. Plug in the 2 for the x. Plug in the negative 4 for the y. You don't know what z is. But now look at this. This is pretty easy. 2 times 2 is 4. Negative 4. What's 4 minus 4? That's nothing. So it's just z equals 1. These cancel out. So your x value is 2. Your y value is negative 4. And your z value is 1. So remember, with a system of equations and three variables, you've got three answers. It's okay if you write them down here at the bottom. You don't have to write it at the top in the point like I do. Also be aware that when you're not dealing with a word problem, it's okay to get negative answers for your values. But when you're dealing with a word problem, be careful, because a lot of things in life, we don't need that negative answer. We're talking about things like we talked about in class with this example of the people who placed in a swim meet, or the people who were buying tickets, and we had a number of tickets. So when you're in a word problem, just make sure you're careful. Remember, though, I'll try to give you as much partial credit as I can give you, as long as you are showing me you understand the process, even if you kind of mess up one of the equations. So don't give up and don't stop too early when you're dealing with three variables.